and thanks for being here. The reason why I'm giving the talk is of this guy, who is Thomas Edison, the guy who found the electric bulb. So electricity, light, and this changed our lives, having light, the way the time of our lives, the way we organize our lives, and it's not so much necessarily the issue of duration. I have to stay here because of the recording, but I will be coming down also. So it is not necessarily about the duration of sleep that changed so much. We have very few studies, but very interesting, from the few populations of hunters-gatherers, the way we were living 5,000 years ago or 10,000 years ago. And there are some populations who still live like that in Africa and in South America. And they have done studies on them and also looked at their sleep patterns. So they sleep more or less, if we assume that they continue sleeping as they slept thousands of years ago, they sleep about 7 to 8 hours. 7 hours in summer, 8 hours in winter, which is more or less the amount of time we sleep on average. So when the sun goes down, they just put some fire, they sit around the fire, they talk, and then they go to sleep. And before the sunrise, they start waking up because of the temperature, the animals, and whatever. So it is not necessarily the time of sleep, the duration that has changed, but what has changed is the timing of many of our activities. And this is what I'm going to talk about, how the big changes we have in our lives, because of the availability of light, how could this affect our health? So I'm going to talk about night shift, complete reverse of the day-night schedule, which has been associated with different degrees of evidence, with obviously immediate effects like sleepiness, but also cancer, cardiovascular diseases, metabolic syndrome, obesity. I'm going to talk about not so much about sleep, but about light and how it affects sleep. So, and the type of light we have when we go to bed and read from our light-emitting readers or tablets, that is the type of light that actually, it's blue light spectrum, very bright white light that LEDs, LEDs emit, and tablets and TVs that actually is the type of light that suppresses melatonin. Melatonin is the sleep hormone, to say it in lay language. Not necessarily on diet about what we eat or how much we eat, which is the typical thing we have been looking, but when we eat, at night or early morning. And also concerning diet, the story of time-restricted eating. This is comes out in the popular magazines. It became popular because Jack Dorsey, the Twitter guy, he eats once a day, and he's promoting that. And there are loads of books if you go to the airports on nutrition, and they promote things that not necessarily are based on very, very solid evidence. So we were not working on circadian disruption. And we were planning big studies on case control studies on several cancers. And then 2007, more or less the time we were planning the study, the WHO, the International Agency for Research on Cancer, did this evaluation. These are normal evaluations that IARC is doing on the carcinogenicity of shift work involving circadian disruption, and classified it as a probable human carcinogen. This is the second strongest category. If it's group 1, there's no doubt. Human papillomavirus, hepatitis virus, tobacco smoking, asbestos, and also all sorts of other things, ionizing radiation. 2A is the second strongest category. There are 2 more. So pretty strong, which came as a surprise. And this was done, and IARC is evaluating all the type of evidence that exists. And this was done on the basis of very strong evidence on animal studies. So you put light at night to female mice and female rats, and they do cancer. They develop cancer. And not very strong evidence, what is called limited, for breast cancer among women working at night. So this came as a surprise, and this motivated my group to get into that, and then we have been working since then into that, and that's what I'm going to talk about. So the type of epidemiological evidence that they had was, you know, not bad. I mean, look at this. This is a summary of the evidence they had for breast cancer. You know, this is the pooled estimate is 1.48. Pretty consistent, but they still said limited evidence. They were not convinced. And the reason why they were not convinced is because these were very basic studies without, many of them were based on administrative data, no control of confounding, very little information on night shift work. It would be on pilots doing transatlantic flights. They definitely have jet lag. They definitely have circadian disruption, but not very detailed information. So they were cautious, which was good. And so they said limited evidence at that time for human. Apart from the cancer data, there was around animal data, apart from cancer, on other effects, like this one. In fact, the strongest associations are for cardiometabolic, not for cancer, which makes more sense in reality. So look at this graph. This is an experiment with mice. They are genetically exactly equal mice in the two groups. And one group of mice are given their food. It's a hypercaloric diet during the day. And the other group of mice are fed during the night. And as you can see, there is a very, very clear difference. It results that, obviously, rodents are nocturnal animals. So the day is not the time they're eating. Contrary to us, it is the night the time they're eating. So they eat the time that they are used to eat and metabolize, and you know, they gain some weight. And you give them this hypercaloric diet at a time that they are not ready for this diet, because normally they're sleeping, and they became obese. So, and this type of experiments also led my group to get into also nutrition and circadian disruption. I'll give some results on that. So the questions following IARC evaluation, which was quite strong, is, first of all, is it true or is it confounding? The studies we had were not very elaborate on confounding. We know now that obviously there is some confounding going on. You know, people who like working at night for many years tend to be different in many aspects of lifestyle compared to others. Diet, physical activity, exposure to sunlight, but not so much actually. Now that we have studies that evaluated different factors, confounding doesn't seem to be the biggest issue here, which is surprising. But it doesn't change very much our results when we adjust for a number of lifestyle factors. So, but that was an issue. How big is the risk? They came up with about 50% increased risk, which is pretty much. 50% increased risk breast cancer, you know, the most common cancer in the world. 15% of people working night shift, so it's big. So how big is the risk? You know, we couldn't really rely on the existing studies. Is it only breast cancer? Why only breast cancer? It's an hormone-related cancer, but we have other hormone-related cancers, if that is the pathway. So prostate cancer, for example, in men. Is it only cancer? What we know from animals is that we have pretty strong effects on cardiometabolic. And then what are the mechanisms here affecting so many different health outcomes? And that's important not only for causation, for establishing causation, it's also important for prevention. If we understand that if the mechanisms are all via melatonin, then you have different types of prevention measures. But if there are different mechanisms, then again, you can take maybe some measures, different measures of prevention. are the people who are more susceptible. You know, if I ask you, who among you are morning persons and who are night persons? You know, there are people who function in the morning and people who function at night. And we know that for ourselves. I mean, you are not a morning person. I know that. He just told me. That's why I know it. So, whether you are a morning or a night person, this affects clearly whether you are more tired if you do night shift. If you are a morning person, you get more tired. Does it affect your long-term risk? We don't know that. But it's something to take into account, apart from the genetic aspects. And hey, we are in a 24/7 society. So even if it is bad for our health, you know, there's no way that we will stop using electricity at night or stop using our smartphones or stop using our tablets or stop having transport at night or restaurants at night or whatever. There's no way. But there may be some ways of prevention measures if we think that we can change the time when people go to work or start work in the morning, or if we allow, for example, people doing night work to take a nap in the middle. So there are a number of things you can do. But obviously we cannot abolish night work or our exposure to this extra light that we are getting at night. Legal aspects. So what do you do if a nurse who has worked 20 years as a night shift gets breast cancer? Is this an occupational disease? If it is, she gets compensation. So there are legal aspects here that are not well solved. And obviously, it started by looking at an extreme situation of night workers who really reverse the time. But if we think of it, we are, all of us, exposed to minor degrees of circadian disruption. We all of us stay late at night. We all have tablets. Some of us, you know, in our clinical work, we do every now and then night, not very much, but just a bit. So does it affect the general population? So these are a number of questions. You know, from my group, we tried to respond to some, and there are many other groups, obviously. This became a big area of research. So this is how we were not so long ago, 200 years ago. And, you know, that's it. This is it now, down here. And this is nearly everywhere. Not everywhere. I'll show a global map, but in many places, like that. And what we are talking about is about circadian misalignment. So we have an internal time, and I'll talk about it in a minute, and we have the external time. So when these go together, that's okay. But in many situations, they don't go together. Our internal time says it's 3:45, and our external time says it's 2. Because of jet lag, because we work at night, because we party, because we like staying late, whatever. So this is the issue. Circadian rhythms have been identified since a long time. They have approximately 24-hour circadian, not exactly 24, nearly 24. And they persist even if we close the doors, we stay here with no light, even with no light and no food, we would still have a pattern. And they obviously adjust to local times. If we go, all of us, to Japan, in a few days we will adjust to the Japanese time schedule. And they affect lots of processes in our bodies. So we know that our temperature is lowest in early morning, our blood pressure is highest more or less now, melatonin gets high later at night, and so the number of autonomous processes like body temperature, hormones, and lots of genes, lots and lots of genes that are controlled by it's not only the clock genes, it's that the clock genes that are very specific control many other genes. So it's of the order of 20 to 30% of the genes have some kind of pattern during the day. So if it is like that, it means, you know, we can affect lots of functions in our body because lots of them have a circadian pattern. There is a central clock in the basis of the brain, which depends on light. That's in the suprachiasmatic nucleus. So it really depends on light. This is the main factor affecting our circadian pattern. And this is connected to to our whole body. But apart from the central clock in the hypothalamus, we have peripheral clocks. So when we are traveling to the States, and you have you have jet lag, and you have some sort of gastro feelings, it doesn't work really well, that's because your local clocks here are not entirely aligned with your central clock that adapts quicker. That's one of the reasons, at least. And then you have clocks in the liver that affects glucogenesis. You have clocks in the pancreas that affect insulin, clocks in adipose tissue that affect leptin, clocks in the immune system that affects cytokines, etc. And when you start having circadian disruption, it's not only that the central clock, but it's the whole body that is affected. So let's see at the human health effects of night shift. First of all, how common it is. We have very good data for many countries. There are a number of colleagues from Nigeria and Uganda and Mozambique and Ethiopia and Cote d'Ivoire. We have less data. We have some data from Africa, less data though. But it's common also in Africa. We know that from the little data we have. In Europe, it's about 15% of people do night shift. And there are some industries that it's more common, like hotel and restaurants, transport, and health, as you can see from the photos. So pretty common. So let me put you a first question. Which shift do most workers try to avoid? They try to avoid morning shift. No, so you have two options now. It's not morning shift they try to avoid. Night shift people get better paid. It's evening shift. Most workers try to avoid because you don't get better paid and you are fully out of the social life of your family and the rest of your friends. So evening shift is the one that when you talk to workers, I mean, they don't like night shift, many of them, if they are obliged especially to do it if they're not volunteers. But evening shift is pretty annoying because you gain nothing. You have still the traffic to go to your work and back. You don't get paid, and you cannot go to collect your kids from the school. You can't have dinner with your kids, et cetera, et cetera. So it's not night shift, actually, it's evening. What are the risks? There are the obvious ones, the obvious immediate ones, sleepiness, impaired alertness and performance. These are important ones. Think of a bus driver. You don't want a bus driver to be sleepy. You don't want a surgeon to be sleepy or a nurse to be sleepy when they do their practice. And you don't want workers in a factory to be sleepy because they have accidents. So they have bright light, which means they have even more suppression of melatonin. So immediate things, and then we have the chronic illnesses. I mean, these are obvious, they are well documented. These are less obvious. Cardiometabolic cancer, mental health is a new one that's coming out, and reproductive outcomes. And then the whole issue of balancing your life of work and your life with your family. That creates long-term anxiety and mental health type of effects. Let's see this plots of sleep. This is a plot of a doctor. This is a plot of a nurse. Black is sleep. White is the time of work. And so for consecutive days. If you look at it, sleep duration, let's look at, in this case, in the part down here, sleep duration between evening and day shift was considerably truncated. So in this case, this nurse worked one day the evening and then the next day worked in the morning, which meant that she had a shorter time of sleep. You don't want to have many short sleeps. Sleeps affect very much your health. So, first thing. The second thing is that doctors could take a nap while they were working, which is good. I mean, nurses should also take a nap, but it's a doctor taking a nap in this case. And then sleeping during the day, this is, they have done night shift, so they sleep during the day. As you can see from the length of the bars is again shorter. They don't sleep enough. This is not the case always, but we clearly have sleep being affected by night shift work, especially when it's so irregular, when it's not long-term night shift. So 2019, we had the second monograph from IARC. So in this one I participated, and that one I didn't know anything about night shift. So, but this one I participated. And we had 12 years of research in the middle, and we concluded the same, unfortunately. We concluded that there was sufficient animals for animal studies, and there was limited evidence in humans. We added 2 cancer sites, not only breast, but prostate and colorectal, but we didn't have enough data, not only the epidemiological data, but also the mechanistic data. IARC takes into account animal data, human data, and then mechanistic data, mechanism. And this could be cells, or it could be studies on molecular epidemiology. And the mechanism data in humans were really not well developed. So it couldn't help very much. But after 12, it was very disappointing. After 12 years of research, very, very intensive research, we couldn't, in fact, conclude whether it was definitely a carcinogen or not a carcinogen, which is what you would like. You don't like the intermediate categories, which is a problem. And research goes like that, unfortunately. Especially in situations where risk may be there, but are not necessarily super high, where it's more difficult to show an effect. So it was good that the first group didn't say the human evidence was sufficient based on not very good studies, because the evidence that came after were less clear than the one they had in 2007. We have a series of cohort studies that were negative. The biggest is one from Oxford, with about 500,000 women, and it was negative, basically. But the best analysis was a pooled analysis of about case control studies that had very good information on shift work, of about 6,000 cases with breast cancer and controls, and you can see the results here. So this is ever night shift, all women, premenopausal, postmenopausal, and these are the ones that would have sort of more serious night shift work. Again, all women, premenopausal, postmenopausal. Yeah, there is something there, for sure, but it is not really entirely convincing. We don't have a very good explanation why, this is okay that, you get the higher risks, 1.8 is pretty high, in fact, for premenopausal women is really important. But then you get this one for postmenopausal women, which is unexpected. We have some explanation for that. And one of the explanations is that actually the risk goes very quickly down. We know that for many carcinogens, you get the exposure, you stop the exposure, and then the risk goes down. And the risk for smoking goes very slowly down. For smoking and cardiovascular, it goes much quicker down. For hormone replacement therapy, for some effects, it goes very quickly down. So, and we have some evidence, both for breast cancer and prostate cancer, but not entirely convincing, that actually it goes pretty quickly down. You stop being a night worker and it goes down. If this is true, this can be an explanation for the null findings in postmenopausal women, many of whom are not anymore working, because night shift work is much more common in early years. But still, this is not entirely consistent. So, and this is one of the reasons why in 2019 we ended up again with limited evidence. For prostate cancer, perhaps the one we did in Spain is the most informative ones in terms of, well, there are a couple more that are very good, in fact, the French and the Canadian. And these are the findings we have. So for, ever, and then for the taking into account duration, a number of nights, and that's very important. For sure, you don't get any long-term effect if you just, party one night. For sure, you don't get breast cancer if you just work for a year as a night shift person. You really need to accumulate. that's what all our studies are saying. So, this is the most informative. And we do get an increased, 30, 40% increased risk for prostate cancer. And the French study also has similar findings, and the Canadian not. So this is the issue. We do find a lot of positive signals, but results are not entirely consistent. So we ended up with limited evidence. We just could not discard some of the studies that were the best studies we had, but results were not so consistent to say, hey, this is for sure, associated with human cancer in humans. Why did cohort studies didn't find an effect? Actually, not all of them. There are some that found, but most cohort studies actually didn't find an effect for breast cancer. That was the main discussion. For one thing, if the ever-never comparison, would give you a relative risk of 1.1, it is not at all difficult to miss it. Just a bit of exposure misclassification, it's out. It's really easy not to get it. And the cohort studies, unfortunately, they didn't have good exposure information. Certainly, they did their evaluation, excluding the prevalent cases, so they wouldn't have recall bias, but they had not collected this information prior. So all the exposure evaluation was retrospective in the cohort studies. So you didn't gain the advantage of having, in the cohort studies, prospective evaluation of exposure. So they asked, what were you doing before? And some actually asked for a limited time period, which was entirely wrong. So, but this we could discard. But the big Oxford study asked for lifetime. But they got the women when they were 68 years old. Basically, nobody was working. So there are lots of things that could have gone wrong with exposure assessment. And you have a relative risk for ever, never, of the order of 1.1, 1.2, and you've lost it. It is not easy to lose it. And in this case control studies had much better that were focused on night shift. They were much better evaluation of exposure. So this is perhaps one of the reasons why we have this difference between case control and cohorts. But we were there in the working group of IARC, and we certainly said, okay, case control studies give some support. Most cohort studies do not, some do. So we really cannot conclude that it's a proven human carcinogen with this data. I mean, we seem to have a signal, so limited evidence again, unfortunately. Which is important because this, would lead also to more preventive measures if they were needed, obviously. For cardiometabolic, the evidence is stronger. This is the Nurses' Health Study, very big study in the United States, and the pattern for duration of shift work with obesity. It doesn't really matter the certification they do. It's pretty clear, okay, it goes a bit down here. Basically, there's a very clear pattern for obesity, similar to what we have in animal experiments. Well, they don't work at night, the animals, but comparatively. So, and these are the meta-relative risks for myocardial infarction and type 2 diabetes, although some of the studies that we have loads of meta-analyses. There are more meta-analyses than original studies, by the way, in this topic. So we have loads of them, and many of them have not really evaluated the quality of the information, but still, it is pretty clear that you have positive relative risks and for myocardial infarction and for type 2 diabetes, which is consistent with the mechanisms. And some of this, signal cohort studies like the UK Biobank, actually is finding this thing. What about susceptibility? Susceptibility has focused on chronotype. This is how, we would be distributed. Most people are sort of normal people, classical Gaussian distribution, and some are very early, some are very late. And we basically, practically in our lives, we know what we are, and we try to adapt. In my group, we take very seriously that stuff. So, since some are morning types, we never have early morning meetings, by definition. And we really have very little evidence on the effect of chronotype on long-term effects. We have done this analysis in the studies, both in my group and others, but we don't have much, and we don't find a clear association that early morning workers would have higher risk of breast cancer if they're shift workers. We don't find it. So the acute effects are clear. Early morning types, if they work at night, they are more sleepy, this we know. Whether they have more long-term effects, It could be, but we haven't found it. And the idea of the susceptibility relates to adaptation. So this is, us. Awake during the light time, then as night comes, melatonin goes up. That's what should happen. If we party, say, or whatever, for one day, still, we will keep our rhythm, basically. The melatonin will not change so much. If you party every night during your course, at the third week, this is what will happen with your melatonin. It will peak during the day, basically, so you will lose all the classes. So this is, the way that people adapt, actually, is not exactly the same. Some people adapt quicker, some people don't adapt, and you will see some graphs in a minute. So we were interested in looking at mechanisms because we thought that was a missing part in the literature. So among the studies we have been doing this is a small study because it has been very difficult to get more people. It's 50 people working in a Volkswagen factory, in a SEAT factory in Barcelona. Well, everybody, 9,000 people, they're obliged to do that. They work 3 weeks night, 3 weeks evening, 3 weeks morning. Apart from the fact that this is wrong, these are details. So we got them at the end of the 3 weeks night and at the end of the 3 weeks morning, the same people. So as to avoid confounding, so we didn't have, basically, it was within-person comparisons. When they were already adapted to night, when they were already adapted to morning, although you are never really adapted to night because you have weekends with your family, but more adapted. And then we did lots of stuff. We had light and physical activity, and we got all the urines for several days, and we had blood before and after work here and before and after work here. So the after work here was 6 o'clock in the morning, and the before work here was again 6 o'clock in the morning. So they are comparable in terms of circadian time, which is where we're doing the comparisons for the blood. The biomarkers we did in blood. Okay? Because that's tricky. You take blood, somebody 6 in the morning, and then you get blood in the afternoon, and you have ups and downs just because of a circadian disruption. So this messes up entirely our investigation. So you really have to take care for some things that vary during the day to monitor also the time that you got the blood, not only the other parameters. So we did that. And, these are the type of graphs we would get. So we have 24-hour voids. Every time they went to urinate, they would collect the void, and then we would analyze. This is for melatonin, well, for the metabolite of melatonin. And you can see, how we reconstruct the pattern. We have all these measurements, the red dots, and we can reconstruct with a cosinus analysis. And you can also see that there are some people who don't have very pronounced circadian patterns. This one. And this is normal. We always find it. So we could reconstruct, this is melatonin. We could do it for other hormones that are also related, have a circadian pattern. And you can see the difference between, these are the same people. This is within person comparison. These are during the day, melatonin, peaks are early morning. When they work at night, they go to sleep during the day, so it peaks early afternoon. And there's a difference of 9 hours. Which is huge. So the area under the curve also is slightly different. If you think of the area under the curve, how much melatonin they produced, the night workers produced a bit less, not much less though. They were really adapted. But they got the melatonin in a way in the wrong time. And this is a pattern we saw with many hormones. You will see that in a minute. Not necessarily lower production, but definitely wrong time. And we know from mechanistic studies that this is also important. It's not only how much you produce, but when you produce. So these are the patterns for sex steroid hormones. And we want sex steroids because of prostate and breast cancer. And these are all men, by the way, what we did. So this is one, and it's night versus day shift, within-person comparison. And you get all this chunk here that are the androgens that peak much later and you get the progestogens also peaking much later, and then you don't get anything about the estrogens. So we definitely have big changes in hormone secretion. And that's as far as we can go with this study. We can say androgens that we know are important for prostate cancer, are modified, their time, and in fact, their overall level of production also, but to less extent. And then we looked at cytokines, at immune function. So we look at cytokines, chemokines, growth factors. And again, it's night versus day, and you can see, fairly clear differences for pro-inflammatory cytokines, TNF-alpha, and also for growth factors. And there are interpretations about that. It's not homogeneous. Some things are not affected, but some things are affected more than others. So we definitely can show that it has an effect on the immune system. And it's ridiculous, but this with 50 workers twice is among the biggest studies on these things, on these pathways. After all this time, we had not managed to produce for the IARC evaluation good molecular EPI studies, unfortunately. And this came after the IARC evaluation. And we also did metabolomics, and well, I'll just pass from that stuff. And there are a number of changes, both metabolomics and in gene expression. So let's move to light. So to conclude the previous one, we have signals, pretty clear signals that there are a number of cancers and other, definitely cardiometabolic diseases. And we have not as strong data for mechanisms, for pathways in humans. We have experimental data, but not in exposed humans. This is among the best data you would get. So, light at night. Here you have the darkest part of the world. This is reconstructed, obviously, from many satellite images. The darkest part of the world, the brightest part of the world. And basically, you can see you have lots of parts of the world that are very bright at night. So that's what we're talking about. And this is a picture from the desert in Arizona, and you can see all this really beautiful sky with stars. So this is Arizona looking west, and you can see the sun rising. Only it cannot be the sun rising because we are looking west. So if we zoom in, that's Las Vegas. That's Las Vegas, about 150 kilometers away. So that's what we're talking about when we're talking about artificial light at night. Las Vegas is extreme, but there are lots of extremes in this world like that. So the astrophysicists, they talk about the inappropriate or excessive use of artificial light, and they're talking about external light, basically. We, as epidemiologists, were also interested in light inside. Tablets, TVs, LEDs in our house. So it is the external light and the internal light that we're interested. And this is what happens with the lights in our countries. Now the cities practically everywhere have changed lights to LEDs, to LEDs. And the reason why we have all this lighting is because you have this glare zone that, gets the light upwards where you don't need it really. You need the light being targeted in our cities, but by definition, because we have so much light, it just goes everywhere and inside our houses. Look at this beautiful picture from Sydney, where you have this, if you look carefully, these are the trails of birds flying around the Sydney Opera because it's very lighted and they're attracted. So one of the effects of the very strong, lighting of the planet is basically in animals, in birds, and migratory patterns that change a lot and that are associated with very clear effects in the mortality of birds. So most of the research for external light is actually in ecotox, not in humans. We don't have much in humans, but there are very clear effects of the external light in birds mostly. So what is the evidence in humans? Let's see, we're talking again about this type of patterns. And let's first discuss the issue of wintertime and springtime. This is the wintertime and springtime in Barcelona. So if we had wintertime in summer, we would have light at about 5 o'clock in the morning. but we are changing into springtime. So we just bring it up 1 hour, as everywhere in Europe. And we have, in the summer, light at about 6 o'clock in the morning. If we extrapolated this curve to winter, and we didn't switch to winter time, we would start having light in winter in Barcelona at 9 o'clock in the morning, not 8 o'clock, as we have now, because we switch. This is an ongoing discussion, not only in Europe, but in many places. And in some Nordic countries, obviously, this pattern is much more extreme. And in countries from our colleagues from Africa, it is less extreme, near the equator. So, if I ask you, should we change times? I mean, this has been discussed. Should we not change? Because the changes, people get jet lag. It's massive jet lag. The whole, 450 million Europeans get 1 hour jet lag at specific times, twice a year. Should we change? Because the change help us adapt to the sunlight, or should we do like the chicken that just follow the sun? And I have to finish, and I have about half my talk yet. So,
it's 18 minutes to.
Okay, so I'll finish. I'll go very quick. So this is the situation we have, and the people have different opinions. The best option is this one, but we cannot do that, unfortunately. So these are the two options, and there are pros and cons for both options. So this is the one of the best studies we have on indoor light, an experiment. 5 days having an e-reader, 5 days reading a printed book, how it affects your sleep. And the e-reader means more exposure to blue light, and clearly effects on sleep and on melatonin secretion. They're not very clear here. You can see it here. And the issue here is that the best study we have is based on 12 people. It's experimental, so it is stronger than what you think, but it's based on 12 people, and it's based on an exposure of 4 hours of e-reader or 4 hours of printed book. So it's quite long. But, 2 hours is pretty common, is not uncommon. But so this is the best evidence experimental in terms of light. And we have a number of few cohort and case control studies looking at satellite images, the American looking at this one, and then the one we did in Barcelona, where we had this picture from the International Space Station. It's a digital picture, and we can zoom in to a grid of about 30 meters by 30 meters in front of the houses of the people, see how much light they have. And because it's a digital photo, we can identify whether it's blue light or not. And we found these very surprising findings of higher risk for breast and prostate cancer, and they're surprising, but that's what we found. The issue for light exposure epidemiology is what do we do with indoor light? The outdoor light we can manage with the satellites. The indoor light, unless you have sensors and measure for a long time the people, you just cannot evaluate it well. I'll put just a couple of slides on chrononutrition and I'll finish. This I've showed. So what is being discussed now is not only how much you eat and what you eat, whether you're vegetarian or not, but when you eat. So you have different patterns. You can eat a lot during the 24 hours, or you can maybe not eat at all, which is, you get thinner. So, and there are intermediate patterns of whether you eat during the day or you eat also during the night. So this is what has been investigated. We and a few others, and not many studies on cancer, have shown clearly decreasing trends if you eat earlier or if you leave enough time to metabolize before you sleep. The French study also found the same for people who were eating late. So quite a big effect on breast cancer, prostate cancer. And one of the big issues is what happens with the story of time-restricted eating. If you don't eat for many hours, which is what experiments in rats tells you whether you are protected or not. One of the things we are working is not only whether you eat or not, but when do you don't eat? Do you don't eat during the day, or do you don't eat during the day and the night? So the whole pattern of circadian rhythms. And just to put one result from one of our doctoral students from a very big study, in France. For time-restricted eating and type 2 diabetes, this is among the biggest studies there are. We don't find an effect for people who do nighttime fasting for 12 hours or more than 13 hours. We do find an effect if you have a more circadian pattern, but not very clear. Very clear for more than 13 hours if you have an early breakfast. But this is preoccupying. It should have been. We should have get a better dose response. And if you have a late breakfast, which is not what you should be doing, in principle, no effect of time-restricted eating. This is the biggest study on type 2 diabetes. So I'll finish with that, just putting the people in the group more involved. Anna is finishing her PhD. Barbara is a postdoc, more on molecular epi. Gemma, we have been leading together the studies. Anna is biostatistician. Kyriaki now is in Vienna a long time. She's associate professor, but she participates in all our studies. She started with us. And Kurt was the ex-head of the monographs of IARC, and he is also associated with the group. Thanks a lot.
We've got time to go back